Hello and welcome to our webinar on vertical translations. This is day 2, and this lesson needs to be watched before 4:28. And so we're going to talk about vertical translations, and what that basically means is how a graph is moved up or down. That is a vertical translation. So we are going to sketch the graph of the quadratic function. And so if I was going to quickly sketch a graph, I would set up a set of axes, something like this. And one thing that I know about a quadratic function is that it is U-shaped, and that's something that hopefully we figured out as we were doing the other graphs in our practice graphs. And so I'm just going to go as simple as y equals x squared. That is a quadratic. Anytime one of the x values is squared, that's the highest power, you end up with a quadratic function. So a quick little sketch of the graph would be a U-shaped graph just like this. And so that is what I'm looking for a quadratic function and its equation. So we're going to talk about translations and transformations of functions, or vertical translations. Basically, when we translate something up or down, we're talking about it has to be outside the function. And so if my function is a quadratic, as is this x squared down here at the bottom, the 2 is outside the function. When it is plus 2, it's x squared plus 2. You'll notice that this one right here is x plus 2 all squared. This bottom one that I'm going to underline in green, is a horizontal translation, because when it's inside, it's horizontal. When what we add or subtract is outside, it is up and down. So that's what we're looking for. This part right here is what we want, and this is what we're looking for in all of our graphs. We need to make sure that it's outside the function, and so it moves up and down. So let's move along here. And so at this point, we're going to graph a bunch of linear functions here. And so these are the basic functions, and we're going to see how they slide up or down. Well, in this case, if I pick, we've done this one, I'm going to go with 3 points: -1, 0, and 1. So if I plug -1 in for x, I get -1 for y. If I put 0 in for x, I get 0 for y. If I put 1 in, I get 1. So I'm going to get a line that looks something like this. Now I'm going to graph that line with something that I can copy. I'll use this blue line here. And I know that my line will look like that. Okay, so you can see it goes to those points. Now watch what happens here. If I plug in my same points, -1, 0, and 1, well, if I put -1 in here, I'll combine these and I'll end up with a +2. If I put 0 in, I get +3, and if I put 1 in, I get a +4. So if I go to plot these points, -1 for x gives me a +2 for y, a 0 will give me a +3, and a +1 gives me a +4. Now look at these 3 points. Does this line, the black line that I'm going to make here, look parallel to the blue line? Well, let's find out. Let's draw it in and see what happens. If I was to draw this line, it would probably look something like that, and I'm going to extend it in both directions. Oops, I thought I was going to extend it in both directions. Try that again. Extend it in both directions, and so I end up with a graph that looks like that. Now, if I take this graph and actually move it, this black line, does it end up lining up on the other one? Yes, it does. So we have the same line. So by adding 3, we didn't change the line any. The look of the blue line, we just changed its position. It was a vertical shift of 3 units. That's outside the function. So you could probably guess what's going to happen on the next one. And so if I put in my same values, and it's not because I'm putting in the same values that this is happening, it's because the way the function reacts to what I have added or subtracted. If I put -1 in, I get -3. If I put 0 in, I get -2. If I put 1 in, I get -1. So let me plot these points. -1 over and 3 down will give me this point. If I go 0, I'm at -2. And if I'm at 1, I'm at -1. And you can probably tell that this green line that I've got going on here is going to be parallel to the other 2 lines that I have. And so I end up with a graph that looks something like this. And they end up with a parallel line. So you could see, oops, I kind of missed my points, but if I was to move this green line, on top of the blue one, it's pretty much the same. I'm off by a little bit because I wasn't very accurate with my placement of it, but I end up with a parallel line to the graphs that I had before. And so it doesn't matter which one. I can move it here, it's parallel, it's the same line. If I move it up to the black one, it's the same line. It's just what happened is that I have drawn the same line, but because of this +3 and the -2, I have moved the graph up or down, and it's the vertical translations. That's what we're talking about. So here's my basic function. You'll notice I translated up 3 and I slid it down 2, and that's really all we're talking about in this one. So that's the answers to the previous one. So then in this one we have a quadratic function, but it's still, the good thing about translations is any function, no matter what you're doing mathematically, in any function these translations still hold. So I'm going to pick the same values I had before, and I know what a quadratic function looks like. I know it is a U shape, and this is what the other thing you need to get out of this is you need to make sure that you are finding you're recognizing what the shape is going to look like every time you do this. So if I go ahead and plot these points, I'm going to put -1 in. -1 times -1 is +1. 0 times 0 is 0. And 1 times 1 is 1. So I know right now I have a point at 0, 0, +1, +1, and -1, +1. So I'll get my U-shaped graph looking something like that. So now what I've learned from before is since these numbers are outside the function, this graph should move up or down. All right, just depending on what the sign of the number is. So I'm going to try the next one. I'm going to use the same values going into my function. So if I put -1 into my function, I get -1 times -1, which gives me +1. +1 minus 1 will give me 0. If I put 0 in, 0 times 0 is 0, minus 1 gives me -1. And if I put +1 in again, +1 times +1 is 1, minus 1 gives me 0. So you could probably guess that I'm going to end up with basically the same parabola. It's just been shifted down, in this case 1 unit. So I end up with a parabola that looks something like, oops, I kind of messed it up, but it kind of looks something like that. So finally, what do you think is going to happen to my parabola here? Well, because of this +2, it's going to be shifted up. It's outside the x squared, so it should be shifted up 2 units. So I'm going to choose my same values again because they're the easiest to deal with. -1 squared is +1, plus 2 gives me 3. 0 squared is 0, plus 2 is 2, and 1 squared is 1, plus 2 gives me 3. So now at 0, 0, I'm at +2. At +1, I'm at +3, and -1, I'm also at +3. So again, you can see my U-shaped graph looks something pretty much the same, but it's my drawings that are bad, but they look pretty much the same, and wherever they're placed, they're just moved up or down because of this adding or subtracting. And these are what they look like as graphs on a graphing calculator, and I can slide these actually and give you the same picture that you saw before. And so just so you can kind of tell, that's what we're talking about. If I line up the axes, you see shifted down 1, that one was shifted down 1, this one was shifted up 1, or up 2, and it's all just a translation to show that when you're adding or subtracting outside the function, it just slides up or down. These are very important for Algebra 2 and all the math beyond this. So then, does it affect the absolute value the same way? Yes, it does. It affects it exactly the same way. So if I put in -1, 0, and 1, watch what happens. -1, absolute value of -1 is +1, absolute value of 0 is 0, absolute value of +1 is 1. And again, you may be asking yourself, how do I know that this one's a V shape instead of the U shape? Because I got the same points. It is practice of doing this stuff and knowing what the graphs are going to look like, and just doing it a lot. And the more you do this, the more you'll understand what these graphs look like. So to graph everything to get a look. And so this one is not U-shaped. This one is actually V-shaped because it's absolute value for V. So then if I put -2 in, I'm going to get, so if I say -1, 0, and 1, and plug these guys in, -1 is +1, -2 gives me -1, not -2. If I put in 0, Absolute value of 0 is 0, minus 2 is minus 2, absolute value of 1 is 1, minus 2 is negative 1 in this case. So I plot my points. At 0 I'm at negative 2, at positive 1 I'm at negative 1, and at negative 1 I'm also at positive 1. So I will get the same V shape that I had before, but it's just moved down 2 units. And that's the whole idea of these graphs, is that they are the same, but they're just moved up or down depending on the graph itself. So then finally, this one is plus 1, so I'm going to put in my same values. Putting in negative 1, absolute value of negative 1 is 1, plus 1 is 2, 0 should get me 1, and positive 1 should get me 2 again. So if I plot my points, we'll get something that looks like this, another V-shaped graph. And so then I could draw in my line and my absolute value function, and it will look something like this. And so again, you can see that doesn't matter whether it's absolute value, quadratic, linear, the function is moved up or down with the adding or subtracting outside the function. So again, here's the same thing. If I line up my axes, you can see that this one was a vertical shift up by 1, and if I move this one, this was a vertical shift down by 2. And so that's really all we're talking about with these. So then square root, how does it affect